Right, today we're moving on to 1.5, and I've divided this section up into two parts. And today what we're going to be looking at is I can determine the number, kind, and values of roots of a quadratic function. So today what we're doing is we're finding the zeros. So first of all, one thing that we need to know is that the quadratic function is ax squared plus bx plus c, and the quadratic equation is 0 equals ax squared plus bx plus c. So the real difference is a function has y equals, an equation has 0 equals. So when we take a closer look at that, what that means is that when we're looking at a function, there's infinite solutions. However, when I'm looking at quadratic equation, we actually have a finite number, which means we can actually find what they are. So, to solve a quadratic equation, you are finding where the function y equals ax squared plus bx plus c crosses the x-axis. So that's what we're doing. We're finding where it crosses the x-axis. Now, there's different terminology. So for instance, if I'm talking about finding zeros, I'm finding the x-intercept, okay, or finding roots. So all of those mean roughly the same thing. So when I'm finding where it crosses the x-axis, I'm finding the zeros. I'm finding the x-intercept. I'm finding roots. And we'll talk a little bit more about the slight differences between all three of those. So now there are two ways to solve a quadratic equation, and those two ways are factoring and the quadratic formula. So first of all, if we look at factoring, so factoring is based on the zero product law, which states if a plus b equals 0, then that means that either a is 0 and or b is 0. So that's what we're doing here. So a is 0 and or b is 0. So let's look at the first example. So the first example is x squared minus 9 equals 0. So what do we do here? Well, we can do it a couple different ways, but the first way we're going to talk about is we're going to factor. Okay, so we're going to factor that in order to find where it crosses the x-axis. So if I look at this example, I can factor it, or I could solve it a different way, but let's start with factoring. Two terms separated by subtraction, perfect squares at both ends. So I know that it's a difference of squares. So I know that I have x minus 3, x plus 3. Okay, so I now have it factored. Then I'm going to set each bracket equal to 0. So that means that x minus 3 equals 0, and or x plus 3 equals 0. So they're set to 0, and what I'm going to do is I'm going to solve for x. Now you can see solving for x, just little tiny linear equations we're finding here. So this is 3, and obviously this one's negative 3. And the fourth step is answer needs to be in a solution set. Now it depends on the teacher you have in grade 12 whether they want a solution set or not. Sometimes they're just happy the way it is right now. Some teachers prefer a solution set equals and literally putting in the answer. And that way then the person, the teacher, or whoever is looking at work doesn't have to search all over the page trying to find it. Okay, so as I said, I do like a solution set. I think that it adds formality to your solution. However, when you get to grade 12, it'll depend which math teacher you have, whether they're happy with that or not. Okay, so that is factoring. Now, we spend a fair amount of time reviewing factoring, so I'm not going to do any more questions like that. Now, the quadratic formula is the other method that we can use. And it was actually developed by completing the square. Now, one of your questions in your textbook, either today or the next day, will have you actually trying to complete the square of this equation. So hopefully you can try that and see how you go. Now, you spent a lot of time on this last year, and if you do not know this formula off by heart, you need to get it off by heart because it's considered an assumed knowledge. Okay, so when you get to grade 12, they're not going to review factoring. It's just assumed you know how to do it. It's just going to be assumed that you can pull out the quadratic formula anytime you need it. Okay, the important thing is this plus or minus represents two x values. Just like when we factored here, we ended up with a positive 3 and a negative 3. The same thing happens here. We end up with two solutions when we're doing this. And we'll show you in a second with our example. So the first example says solve and round to 3 decimal places. So the first thing I want to do is I do want to try to see if I can factor it. Because actually factoring is faster and less chance of an arithmetic error than the quadratic formula. I'll tell you right now, this cannot be factored, so it means I'm going to have to bring out the quadratic formula, and I would expect that every time you have to use it, that you actually write down the formula. Just don't start substituting things in. Okay, so that's my first step. Then I go through, and sometimes this is what I do, is I go A is 7, B is negative 2, and C is negative 2. Sometimes I do that right underneath the question, and that way I don't have to go look back at it again. So B is already negative, so I have 2 plus or minus the square root of negative 2 squared minus 4 times 7 times another negative 2. Really be careful that if you have negative values for your A, B, or C, that you are putting them in the formula. Otherwise, you will create a negative under the square root when there shouldn't be. Okay, so step 1 is give me the formula. Step 2, substitute the values in. The next step, I just want to know what that equals. And I think if you take that, you get the square root of 60, and it's over 14. Now, because it says to 3 decimal places, I'm going to take that square root of 60, and I'm actually going to calculate it. And it's 2 plus or minus, and I think it is 7 point, let's take a look, 7, 4, and it's going to round to 6 all over 14. So it's at this point that I separate my 2 roots. So the one root is 2 plus 7.746 divided by 14, and the second one is 2 minus 7.746 divided by 14. And then what we do is we just bring out our calculator. Watch your order of operations here as well. So here it is, clear that. So we have 2 plus our 7.746 equals divided by 14. So if I round it to 3 decimal places, it says so 0.691. And if we do, 696, didn't copy that round right. And the second one, when I take it and do it, so I have 2 minus 7.746 divided by 14. So notice this is a negative value, negative 0.410. All right, so I have solved it to 3 decimal places. Now, solution set, depending on the teacher you have. And I'm just going to put my negative value here first, followed by my positive value. Okay, so that is using the quadratic formula. The next thing we're going to take a look at, and I'm going to try to do it without creating another video, but we'll see. Okay, it has to do with exact roots. Now, when using the quadratic formula, instead of using your calculator to take the square root, okay, that square root of this here, you can actually simplify the radical, because remember, all of that is underneath here, underneath the radical sign. And we talked about this already, so this gives you the exact value of roots. Now you're saying, well, why would you do that? It's not useful. Well, actually it is useful. In some programs at university, they don't care the exact the decimal answer. They want the exact so you can move on. So let's take a look at the first one. So it says simplify 2 plus or minus the square root of 32 over 2. So very similar to what we were doing when we were doing the radicals. Now, when we get a form like this, what we want to really watch out for is first of all, is I need to take that square root 32 and I have to put it in mixed form. So the first thing with that, and if you want to take it out, remember that 16 times 2. So if I do that like that, and so I know my next step is 2 plus or minus 4 square root 2 over 2. Now, the top does have a common factor of 2, so I could take it out. Some people might have difficulty with that, so I'm going to take that denominator and I'm going to put it over each term in the numerator. And now I'm going to do my canceling. When I do my canceling here, obviously 2 divided by 2 is 1, plus or minus. And in this case, the denominator cancels out with the 4 that's beside the root sign, so I'm end up with 1 plus or minus 2 square root 2. Okay, and that's your final answer. So if I was doing a solution set, that would be what I would write in my solution set. Okay, now the next one. So we have 9 equals the square root plus or minus the square root of 162. 162, I'm not sure what it is. Obviously, I would try to take out a 2 first. And if I do that, what I would end up with is 2 times 81. 81 is a perfect square. So that means what I'm doing here is going to be 9 plus or minus. Square root of 81 is 9. And I'm left with the root 2 all over 9. So just like the previous example, I'm going to put that denominator over each term in the numerator. And when I do that, and then what happens when we do that, again, we end up with 1 plus or minus. The 9s are going to cancel out, and we're just left with the square root 2. Again, like the previous example, we're going to put a solution set with that monster inside it. Okay, and what I'm going to do now is I'm just going to stop. I do want to do this last question together, but I'm not sure about time-wise going, so I'm going to stop this and then create a part B.